Mr. Harris here, and welcome to a new video of Unit 11. In this video, we're going to do some questions together. We've already finished the reactions of metals with oxygen, water or steam, and finally, in the previous video, dilute acids. So 3 of the reactions we've completed. So now let us practice some questions. This is on practice 11.1. Results of some reactions of metals W, X, Y, and Z are given below. So you have a table over here. The left column, reaction with oxygen. The right column, reaction with water or steam. Let's see the first question. Question A, arrange these metals in decreasing order of reactivity. This means from the most reactive to the least reactive. Okay, for these type of questions, I would first look at the column on the right, reaction with water or steam. And the reason behind it is because metal W gives me a very quick hint that because there's no reaction over here, this should be, or it has to be, the least reactive metal. And because metal X has a vigorous reaction with cold water, that gives me the hint that this should be, or has to be, the most reactive metal among the 4. Now for metal Y and Z, both of them, they have the same reaction with steam. So that is where I'll need to look at the reaction with oxygen. Now for metal Y, it just reacts with oxygen to form an oxide, but for metal Z, it burns with oxygen to form an oxide. Now the use of the word over here, burns, it indicates that this is a highly or more vigorous reaction when compared to metal Y. So in this case, this should be the second most reactive, and metal Y would be the third most reactive. All right, so let me go ahead and write that down. So the most reactive was metal X, and then the second one was metal Z, third one was metal Y, and finally the last one is metal W. Okay, question B, which of these metals could be magnesium for 1, and number 2, copper? So let us go back. Let me rub out so it's easier to see. So first up, magnesium. Can magnesium be metal W? Of course not, because magnesium, there's no way it has no reaction. How about for metal X? Does it have a vigorous reaction with cold water? Not really. It's not able to react with cold water actually. It's only able to react with steam. So again, magnesium cannot be X. How about Y and Z? Because they are the same, so I'll need to look at the reaction with oxygen. Magnesium, because it is high up the metal reactivity series, it is able to react very strongly or burn in oxygen to form an oxide. So it should be metal Z. Okay, you can refer back to the video I made for the reaction of metals with oxygen. Now let's see the second one, copper. Now copper is fairly simple because we know copper, does it have any reaction with water or steam? The answer is no. Copper is unable to react with water or steam, so it's very easy to see that it is metal W. Fairly simple. Okay, let's see question C. A small piece of metal X is added to a trough of water. A metal hydroxide of chemical XOH is formed in the reaction. Okay, this is a big hint. You have, let me use this color, a metal hydroxide being formed. A few drops of universal indicator solution are added to the trough of water. State and explain the color of the universal indicator solution in the water. Okay, so this is, again, we've already done this particular type of question. You can see the question types are repeating again now. So the universal indicator solution, for those of you that might have forgotten, it helps us or tells us whether there's a presence of an acid or an alkali. In this case, because metal hydroxide is an alkali solution, the color of the indicator would become purple or bluish. Okay, you can write purple or blue. That's fine. And the reason behind is because you need to explain because an alkali solution is formed. Okay, let's see question 2. The ore of metal X contains its chloride, suggests how X could be extracted from its chloride. Hey, this is a question from Unit 10, the extraction of metals. So let's go back and see metal X. Which one is metal X? Metal X is able to have a vigorous reaction with cold water. Now, this is a huge hint that it is high up the metal reactivity series. I'm just going to write M dot R dot S. Okay, metal reactivity series. So for those metals that are high up the metal reactivity series, such as potassium, sodium, how are they extracted from their ore? Yes, it's by the process of electrolysis. Okay, so over here, these are the answers. You can have a look. Now let's do practice 11.2. A reactivity series of metals is given. Question A, which two metals will react vigorously with cold water? Okay, we have already done this. We know that the two metals that are able to react vigorously are the ones that should be high up the metal reactivity series. So over here it is potassium and sodium. So go ahead and write that down. Potassium and sodium. Okay, let's see. Question B. Which two metals will not react with dilute hydrochloric acid? Which two metals will not react with acid? And you can look at the previous video when we towards the end of the videos, I've always done a summary. You can go back and have a look, but over here I can already see that copper is here, and because rhodium is even down below, even less reactive than copper, this is also not able to react with dilute hydrochloric acid. Okay, so let us write that down, copper and rhodium. So even though you're not familiar with the metal, but because you can compare the metals that you've known. For example, you know iron, you know copper. So you'll also be able to guess whether some unknown metal will be able to react or not. Okay, so let me rub everything out. Finally, question C. Describe an experiment to show that manganese is over here, is more reactive than copper, and then state your expected observations. So now I need to make an experiment to prove that manganese is more reactive than copper. How can I show that? And one thing that I want you to recall is, or want you to know is, in case if you don't know the answer of this question, most of the time the hints are actually in the previous questions. So question B is giving you a hint already. We know that copper, it is unable to react with acid, right? Dilute hydrochloric. It's unable to react with dilute hydrochloric acid. So in this case, why don't we just do this experiment? So what we can do is we can react both metals with dilute hydrochloric acid. And what would be the observations? For manganese, what will you get? Okay, let me do it like this. This will be for manganese, and this will be for copper. For manganese, you'll get hydrogen gas being formed, right? So let me just put H2, then gas. So you'll be seeing gas bubbles being formed. How about for copper? For copper, there will be no reaction. So there you go. You already have a different observation right now. Okay, but let's have a look at the answer. So similar to what I mentioned, allow the metals to react with either hydrochloric acid or steam. Okay, because copper is unable to react with water or steam. You can do the same thing. And the observations are over here. The reaction is faster. That's one. You can also mention it gives more gas bubbles because hydrogen gas are formed. It takes a shorter time to complete the reaction with manganese. That's also okay. You can also mention another type. Burn both metals in air separately. Only manganese will burn in air while copper does not. Now, this means manganese is more reactive. Of course, copper is able to react with oxygen in air, it just does not burn in air. Okay, there's a difference in words. However, I prefer the first group. I prefer this one because it's more clear. One of them are able to react with acid while the other metal is not able to react. All right? So this wraps up this video. We've done some questions together. In the next video, we'll be starting to talk about how we could balance chemical formulas. All right? I'll see you guys in the next few videos. Bye.